Hello everyone, you're watching Learn with lovejeet. In the previous video, I had discussed what are functions, what is call by value and call by reference concept. In the call by value concept, I said that all function arguments are passed by value. What that means? That means that the calling function will be passing the arguments to the called function, and those the values of those passed arguments are received in the temporary variables in the called function. Now, whatever the operation the called function will be doing on these temporary variables, those the results of those execution will be local to that called function. The result will not affect the actual arguments that were passed. Now let's understand this concept using the example. Here, I have written here a program using the concept of call by value. So this is, as usual, hash include studio.h. I am including some standard input output header file. In the next line on line 3, I have given function declaration. I am telling the compiler that there will be a function named call by value that will take two parameters of integer type and will return a value of int type. Okay, I should here write void only because it will not be returning any value. Okay, so call by value, it will be taking two parameters of int type and it will return nothing to the calling environment. Okay, here from line 5 to 15, from body of main function is there. Now inside the main function, there is a variable named x initialized with value 100, variable named y initialized with value 200. Now using this printf statement, I am printing value of x and y. So what should be printed? X is equal to 100, so 100 will be printed, and for y 200 will be printed. Now on the next line, I am calling, this is the function call, syntax for function call and see. So I'm calling this call by value function and I'm passing this x and y to the call by value function. What are these? I had already discussed the terminology for this. X and y are basically called actual arguments or simply arguments. Now when the compiler encounters this line, so the control shifts from this to this function to from line 11 to line 17. Now here in the function definition, I have defined the parameters name. First parameter is of int type and named a. Second parameter is of int type named b. Inside this function, I have defined another variable named temp. Now I have already told that this a, b and temp are local to this call by value. These are having local scope. That means these are not visible outside this call by value function. Okay. Now here using this printf statement, I am printing a value of a and b, which will be 100 and 200 because x here x value is passed to a, so x is 100, so a will be 100. Y value is passed to b, so y is 200, b will be 200. So but it will be printing 100 and 200. What was printed here? 100, 200. Here what is printed? 100 and 200. Now temp is assigned the value of a. What is a? A is 100. So now temp is equal to a, that is 100. On the line 25, a is assigned the value that b holds. Okay, so b holds 200, so a will be assigned 200. So what now a becomes 200. Now here b is assigned the value that temp holds. Temp holds value that a holds, that is 100, so b will be assigned 100. So what now? Now I will be using this printf statement again to print the value of a and b. So what will be printed here? A is 200, now b is 100. So 200 and 100 will be printed. Here 100, a is equal to 100, b equal to 200 is printed, and here a equal to 100 and a equal to 200 and b equal to 100 will be printed. So I have changed the values. A now holds the value that b holded previously and vice versa. So after the execution of this finishes, when the compiler reaches this closed curly braces, the control shifts to the next line after this function call. So what is the next line? This printf. So what this will print? This printf will print the x and value of x and y again. So let's see what it prints now. Okay. Now here. First line was x and y values printed, so x is 100, y is 200. Okay. Then function was called, then a and b value was printed, so a is 100, b is 200 at that time. Now after this exchange of values, a and b was printed again. So now a becomes 200 and b becomes 100. Now when control goes to the main, the caller of this call by value, then x and y are printed again. Here you can see x and y are same as before, like x was 100 before, now it is also 100 and y is 200. So in call by value, what happened? This x and y values are passed to this call by value. However, these values are received in temporary variables or private copies of variables inside this call by value function. Although a received 100 and b received 200, but x holds this 100 at some different memory location and a holds this 100 at some different memory location. Like x is holding a at some memory location 1000 and a is holding 100 at some memory location 7000. So the x and a both are having same value, but the memory location is different. So whatever the operations or executions that happen on a and b, the results doesn't affect the values of x and y. A and b are basically the private copies of call by value. Any execution that happens on a and b doesn't affect the values possessed by x and y. This is what call by value is. In call by reference, basically, I will be able to change the value of x and y because I will be working on the address of x and y. Pointer concept is used there, so we'll be discussing that in my next videos. But just understand the concept of call by value here. Everything in C is call by value. Okay, so this is about call by value. Now let's move on to a next topic, which is recursion. What is recursion? Now in recursion, a function will be calling itself again and again. Like we have the starting function in C program, which is main. Now if main calls itself again and again, it will be a recursion. Okay, this is what recursion is. A function will be calling itself again and again. Now let's see the example for this. Here I have defined a function factorial. What is factorial? And you must have known this in mathematics. What is a factorial? 4 factorial is 4 into 3 into 2, 24. 3 factorial is 3 into 2, 6. 2 factorial 2 into 1, 2. 1 factorial is 1 and 0 factorial is equal to 1. Here I am calculating 5 factorial. 5 factorial will be 5 into 4 into 3 into 2 into 1, that is 120. Okay, and I am using the concept of recursion to calculate factorial of 5 here. Now here at the third line, I am telling the compiler that there will be a function named fact returning value of type int and receiving a parameter of type int. This is basically function declaration. This is my main function. Inside main function I have defined a variable x of integer type. Now this fact5 will be returning some value of int type. Okay, so on the left hand side I need a variable of int type to receive that value, so I'm using this x of int type on the left hand side. Okay, when the execution of fact5 finishes, some value will be returned and that value will be received in x, and in this line I will be printing that received value. Okay, first let's understand what happens when fact5 is called. Now fact function is called with value 5. N receives this 5 value. Now n is equal to 5. Okay. Let's see one by one here. So now n is equal to 5. Okay. 5 is less than equal to 1? No. So what happens? Control shifts to this else statement. In else, I have written return n star fact n minus 1. So what it will be? 5 star fact 4 minus 1. Okay. Fact will be returning some value to this main function. But before returning that value, this fact function is called again. Okay. Now I am calling this fact function with value 5 minus 1. Okay. So now this is called first executions of all the functions will complete, and then after the completion values will be returned to their respective callers. Now for this fact 5 minus 1, that is 4, caller is this function. Who is the caller for fact 4? This fact 5. Okay, inside this fact 5 this call happened, so this fact 4 will be returning some value to this fact 5. Okay, now this fact 4 is called. So inside fact 4 what happens? 4 is less than equal to 1? No. So control comes to this else part, and then this statement is executed. Okay, now again fact is called and value passed is 3. So 3 is less than equal to 1? No. So control comes to this else part. Now inside this else part I have 3 into fact 2, then fact with value 2 is called. Now control comes to this else part because 2 is less than equal to 1, false. So control comes to this else part, and then again this statement is executed. Now the result will be this. Now this is the tree that that is built during this function call. Okay, so now fact 1 is called. Now fact 1, when fact is called with parameter value 1, here a statement is executed, 1 is less than equal to 1. So what will happen? 1 is returned. So this call resulted in value 1. Okay, what it returns to this fact 2? It returns value 1. So this will be there. Now return 2 star fact 1. Okay, this statement will be returning some value. Okay, so what value it will be returning? It will be returning 2 into 1. Okay, 2. Now 2 into 1 is equal to 2. This 2 value is returned to this fact 3 function, because inside this fact 3 function fact with value 2 was called. Okay, so this 2 replaces this fact 2. Okay, now 3 into 2 is 6. Fact 3 returns 6 to fact 4. Okay, so this fact 3 is replaced with this. 4 into 6 is 24. 24 is returned to this fact 5. Okay, now here the function called fact 4 will be replaced with 24. Now 5 into 24 is 120. Now 120 is returned to the caller of this function fact that passed value 5. Which function did that? Main function. Okay, so fact 5 will be returning 120. This 120 will be received in X, and this value will be printed. Here 120 is printed. Okay, two into fact 1. So this must be clear now. I called the fact function with value 5. Inside this fact function I compared value of 5 with 1. If it is less than equal to 1, return 1, else return 5 into, again call fact function with value n minus 1, that is 4. Now value 4 was passed, 4 is less than equal to 1, false. Then again fact with value 3 was called, then fact with 2 value was called, fact with integer value 1 was called, and eventually when 1 was less than equal to 1, value was returned. This 1 was returned to the caller. Who was the caller? Fact function with value 2. Okay, this statement inside fact 2. Okay, this is my fact 2 function, and inside this fact 2 function I had executed this line. Okay, return 2 star fact 1. Fact 1 gave me 1, 2 into 1 1. When execution of fact 2 finishes, it will be returning 2 into 1 2 to fact 3. Fact 3 will be returning 3 into 2 6 to fact 4. Fact 4 will be returning 4 into 6 24 to fact 5. Fact 5 will be returning 5 into 24, that is 120, to the main function. That where 120 is received in X, and then that value will be printed. So this is what recursion is. Fact call itself again and again. Okay, now there are some important things that you need to know about recursion. First one is, each invocation gets a new and independent set of all the automatic variables. What that means? This n function, okay, this n variable inside each fact function, that is when fact is called with value 5, this n is different. Okay, when fact is called with value 4, this n will be different. That is, fact when called with value 5, fact when called with value 4, fact when called with value 3, 2 and 1. N will be local to those calls. Each call will be having private copy of n, and whatever happens, whatever execution happens, and that copy of n is independent, and in no circumstances changes the value that was passed. Okay, so when I'm doing some execution on n under this fact 4 call, so whatever n is assigned or whatever execution happens on n, that will not change the value of n in fact 5. Okay, fact 5, fact 4, fact 3, fact 2, fact 1 are having private copies of n. Okay, this is what this line means. Each invocation gets a new and independent set of all the automatic variables. This is like that the concept in call by value. When I had passed these arguments x and y to call by value, those were received in A and B. Now A and B was local copy. Okay, same is in recursion. Okay, this local, these parameters that are defined in function definition, these are local copies for function, for each call of the function. Okay, now next one, an activation record or a stack frame is basically, now for each, when we are dealing with this concept of recursion, we need stack. Why we need stack? Because on stack we will be pushing activation records or stack frame for each call of the function. Okay, just know that the only thing you need to know here, that what are these activation recorder stack frames. These activation recorder stack frames are responsible for storing these, like here, this is my call by value function. Okay, now I have defined here a, variable B and temp variable. Okay, now storage for this a, B and temp will be assigned somewhere. This storage is assigned in stack because these are variables with automatic storage class. I have already discussed these concepts in my earlier videos, so you can watch that if you have not watched. So int a, B and temp are having automatic scope, so they will be getting the storage on stack. Now in stack, this storage as this a, B and temp will be private to this call by value. So for each function there will be activation record or a stack frame that will be holding these values. okay, for this call by value function. So an activation record or stack frame is basically a data structure that is assigned a storage on stack frame or activation record will be holding many types of data, and one of those will be the actual parameters and the temporary variables for the function. Like here, temp AB will be getting storage on stack, where these will be getting storage inside the activation record or the stack frame for the call by value. When I'm calling this call by value function through this call, okay, an activation record will be created and pushed onto the stack, and A, B, and temp will be getting storage and values will be received there. Okay, so this is the concept of activation records. So in recursion, activation records are pushed for each distinct function call. When I am calling fact with value 5, there will be one activation record. Okay, when I am calling fact with value 4, there will be one activation record. Now in activation record for fact with value 5, there will be a variable named n that is having value 5. For fact 4, there will be activation record, separate activation record with some variable named n that will be having value 4. Then fact 3, another activation record, another variable n with value 3. For fact 2, another activation record, value of n equal to 2. And for fact 1, there will be another activation record with value of 1 for variable n. Okay. So for each new call, a new stack frame is pushed onto the stack. Now, when this execution of a function completes, this activation records will be popped out of the stack. For stack, we have the operations push and pop. When I am inserting some value into inserting something into stack, that operation is known as push. And when I am fetching some value or extracting some value from the stack, that operation is known as pop. So when the execution of the function completes, the activation record for that function will be popped out of the stack. Okay, so when this fact1 is called, okay, so this function is called n is received value, n is receiving value 1, so this 1 is less than equal to 1, yes, so 1 will be returned. Okay, when this line is executed, the activation record for this fact1 will be popped out of stack and value 1 will be returned to function fact with value 2. Okay, here. Okay, now inside the activation record of fact2, this value that fact with value of n equal to 1 returned will be received, and then this line will be executed. 2 into 1 equal to 2, and the return statement is executed. When this return statement is encountered, 2 is returned and the activation record for fact2 is pushed out, sorry, popped out of stack. Now inside this fact3, this value 2 is received. Now 3 into 2 is calculated. 3 into 2 is equal to 6. That value is returned. When this return statement is executed, the activation record for fact with value 3 will be popped out, and then this 6 value will return to fact 4 function fact with value parameter value 4. Okay, there 4 into 6 24 will be calculated, return statement is executed, and when the control the activation record for fact with value parameter value 4 is popped out. Okay, the value returned will be received inside the activation record for function fact with parameter value 5. There 120 is calculated, and once 120 is returned, the activation record for fact with parameter value 5 is popped out of this stack. Now this 120 will be received in X, this value is printed, and when this closed braces is encountered, the activation record for main will be popped out of stack. Okay, so this is how the execution happens in stack. Also, you need to know that main was the first function that was called. So the activation record for main was the first that got pushed onto stack. And in case of popping, the activation record for main was last, that was popped out. So this is the concept of recursion. In recursion, a function is calling itself again and again, and the values are computed. Also, this is my base case. We need the base case inside the recursive functions to stop the execution. Okay, if I'm not using this base case, then it will be like the program will just not respond. Okay, it will be like infinite loop because I have not defined any condition for stopping the execution. Okay, so the function will be calling itself again and again. The environment will not be knowing, the execution environment will not be knowing when to stop the execution. So inside memory, stack is also having some limited memory only. So when that memory is reached, like I am having 1 MB of stack size, okay, and each function call will be getting some storage inside stack. Okay, so there will be a limit on the number of times a function call can happen. So in using this base case, I am limiting those calls so that the stack memory limit is not reached. But if I am removing this base case line here, so the execution environment will not know when to stop the execution, and eventually the stack memory limit will be reached and we will be getting some unavoidable results. Okay, so this is the importance of base case, writing the base case inside recursive functions. So this was about functions, call by value, call by reference, and recursion. In my next video, I will be discussing pointers, and then I will be covering this call by reference concepts inside the function. Thank you. Keep watching Learn with Ritchie.